Good morning dear students, myself Sachin S. Pawar and I welcome you to my 8th video on Unit 5 States of Matter, Gases and Liquids. In the present video, we will be dealing with the problems on the gas laws which we have learnt. The formulas of the gas laws which are there are on your screen. You see, when we want to solve a problem on any law, any gas law, we need to remember one very important thing, that what are the conditions given in the problem which best suit a particular law, and accordingly which formula to be used, or which law to be used, that has to be understood, that has to be analyzed while solving the problem. And we also need to know the STP conditions. These are the new STP conditions of 0 degrees and 1 bar pressure, and old STP conditions of 0 degrees and 1 atmospheric pressure, and the values of R in different units. We have to also know. We have also know how to find out number of moles if you know the mass and molar mass, mole fraction when you know the number of moles of every component, and partial pressure, that is total pressure into mole fraction, and density is equal to mass upon volume. That also you are expected to know and use it whenever necessary in the given problem. So with this, let us begin by solving some problems on gas laws. Okay. Now before I solve any problem, I would like to tell you that the government has given you a freedom of using a simple 8-digit calculator for calculation purpose, and it is allowed in your annual examination. Okay. So you may need to purchase a simple calculator for your annual examination, right. So here I have a simple calculator where I can use only the digits: multiplication, division, subtraction and addition. Okay. So let's go with the first problem on your screen. Okay. So the first problem on your screen. So when I say read the problem carefully, a weather balloon has a volume of 174 liters when filled with hydrogen at a pressure of 1 atmosphere. Calculate the volume of the balloon when it rises to a height of 200 meters where the atmospheric pressure is 0.80 atmosphere. Okay. So I have just read the problem. Now let us scan the problem and see what they have given. So to scan the problem, I have a weather balloon given to me. See, they have given me a weather balloon. So you know weather balloon means it is a weather balloon they have given. You did not have to draw any diagrams as such. You should be able to find out. Okay, weather balloon. This weather balloon has a volume of 174 liters and it is filled with hydrogen gas. 174 liters of hydrogen gas they have given, and they have maintained the pressure of 1 atmosphere. So pressure is also given 1 atmosphere. What they have done is, this balloon has been raised to an height of 200 meters. So this balloon is raised to an height of 200 meters. Raised to an height of 200 meters, and they found that at that height the pressure is 0.80 atmosphere. See, they have given, and they have asked me to find out what is the volume of the balloon. They have asked. So it is very much clear that they have given two volumes. Let's say this is V1 P1, and if I say this is V2 P2, then you know the volume and pressure is changing. There is a change in volume and pressure, and the atmospheric temperature, let it be a constant. We'll assume that it is a constant since the volume and pressure are changing. So at constant, volume is inversely proportional to pressure, and we have a Boyle's law to be used. The equation for Boyle's law is P1 V1 is equal to P2 V2. So from the given data, now we have to substitute in the given value. We have to find out the volume of the gas, volume of the balloon at an height of 200 meters, and that value is V2. So from this equation 1, V2 implies that is equal to V2 is P1, V2 is P1 V1 upon P2. So I need to just substitute the values. I just need to substitute the values. Let me just bring this here. Okay, so I just need to substitute the values here. So values, let me substitute. So P1 I want to find out. P1 is given as 1 atmosphere into V1 is given as 174 liters divided by P2 is given as 0.80 atmosphere. Okay, so I just have to cancel the units. 1 atmosphere cancels. Unit of the answer will be liters. So I will get so many liters. You can do the calculation orally also. 174 divided by 0.80. I don't want to waste your time in that. I'll simply use the calculator which is allowed in your annual examination. So 174 divided by 0.80. Sorry, 174 divided by 0.80 gives me 217.5, and this is my answer, the first answer. First problem. Let's quickly move on to the next problem because I have to solve more problems, so I am going a bit faster today. So let's move on quickly to the next problem. So next problem. The next problem on your screen is here is your next problem on your screen. Okay. The next problem on your screen is here. Okay, let's read the problem. I say don't read the problem, scan the problem and see what is given, what is asked, and try to correlate between the given things and to be found things. Okay, so I'll just scan the problem here right now. So by heating a gas at constant pressure, okay, immediately I'll scan it. They have given pressure is constant. By heating the gas, so gas is heated from a pressure from a 27 degrees Celsius to 2. So beginning they have taken a temperature of 27 degrees Celsius and it has been converted to, it has been increased to 227 degrees Celsius. Okay, so they want to find out, so certain volume of gas is expelled out from the flask. So simple, what they have done is they have taken a flask whose volume is not known to me, that it has to be found out. Okay, so it is taken at 27 degrees Celsius. So volume of this container, say it is V ml. I don't know what is the volume. So after this I heat the flask to a temperature of 273. So gas will expand and it is observed that 200 ml of volume of air expels out. It's going out. So if I say temperature T2, the new volume of the gas will be the volume of the container plus the whatever volume of the gas which has been expelled out. That is the final volume. Okay, so again you see the pressure is kept constant, temperature and volume is changing. That means we have to apply Charles law. We have to apply Charles law, and the Charles law is T1 by V1 is equal to T2 by V2. So from this equation we can find out the V value. Let's try to find the value of V. So here therefore V1 is equal to T2 into, sorry, V1 is equal to T1. See, V1 will transfer this side, so V2 comes this side upon T2 I'll get. So I'll just have to substitute the values now. Let me substitute the values. Okay, so temperature T1 is 27. Usually remember, temperature need to be converted into Kelvin always. So for that you need to add 273.15 Kelvin to 273.15 you need to add. So convert degree Celsius into Kelvin. So 27 plus 273.15, 27 plus 273.15 is 300.15 Kelvin into V2. V2 is given, okay, V2 is the volume of the flask plus the volume of the air expelled out, that is V plus 200 ml divided by T2. T2 is the temperature at which it is heated, that is 227. So plus 273.15 if I make, then it is I think 500. So it is 500.15 Kelvin. I have got this. So here this is see 227 into plus plus 273.15, that is 500.15. Okay, so we will find this as V. So now this becomes V. So this is V, this is V. Okay, so this is V. So this I will transfer this side now. So this implies 500.15 into V is equal to, I will just multiply this, open the bracket, 300.15. Before that, see, Kelvin unit cancels, unit will be ml. Okay, right. So 300.15 into V plus 300.15 into 200 ml. I'll get V, I'll take it on same side. So 500 minus 300, this when I transfer to this side, 500 minus 200, 500 minus 300 becomes 200.15. 200.15 V is equal to this, I need to multiply, that is 200 into 300.15, that is 60030. So the volume will become 60030 divided by 2. See, ml is definitely there, upon 200.15. So this will come out to be divide by 200.15. I'll get the value as 299.9. If I have to go for 2 decimal point, then this is 5. So if you want to remove 5, 2 becomes 2. Okay, I'll just write this is ml. So I have got the value. This is the answer. This is problem number 2. Let's quickly move on to problem number 3. So problem number 3 I'll go for. Okay, problem number 3. Right. So let me just clean the screen and we'll take problem number 3. So this is problem number 3. You have a gas cylinder containing cooking gas, that is LPG, liquefied petroleum gas, can withstand a pressure of 14.9 atmosphere. The pressure gauge of cylinder indicates 12 atmosphere and 27 degrees Celsius. Due to sudden fire in the building, the temperature starts rising. At what temperature will the cylinder explode? Okay, they have given, so given data, let me write it. So they have given that the cylinder can withstand a maximum pressure of 14.9. So cylinder which has LPG in it, containing LPG can withstand a maximum pressure of 14.9 atmosphere. That means above this temperature, above this pressure, above this, the cylinder will explode. This is a common sense. Okay, now what else they have given? Okay, let's see. They have taken a cylinder. So now you know cylinder, it appears like this. The cylinder, it has LPG in it. The cylinder, it has pressure of 12 atmosphere and temperature is 27 degrees Celsius. So if you convert into Kelvin, that is 300.15 Kelvin, 27 plus 273.15. Okay, now what they have done is they have, okay, the temperature, sudden there is a fire and the temperature rises. So temperature rises to certain temperature at which the cylinder explode. We have to find out this, at which the cylinder explode. We know the maximum capacity of the pressure is 14.9. So if I find out the temperature at which the pressure is 14.9 atmosphere, okay, it is as good as saying that at this temperature, this is the maximum temperature, this is a withstanding temperature, this is the maximum temperature where the cylinder can withstand. Above that temperature, the pressure will increase and you know what happens is the cylinder will blast. So at temperature greater than this temperature, the cylinder should blast. Just to distinguish, let me say this is P1, T1, P2, T2. So at a temperature greater than T2, the cylinder should expand, cylinder should blast or explode, because maximum pressure which can withstand is 14.9 atmosphere, and I am finding temperature at 14.9 atmosphere. Okay. Now here if you see, pressure and temperature are changing, and if you see the container, you know container's volume is fixed. So volume is fixed here. So volume is constant. So volume is constant and the pressure and temperature are changing. That means we need to apply Gay-Lussac's law. So I have the equation P1 by T1 is equal to P2 by T2. So this implies T2 is equal to, T2, I'll transfer this side. So it is P2 into T1 divided by P1, that's equal to P2. P2 is 14.9 atmosphere into T1. T1 is 300.15, I convert to Kelvin, divided by P1. P1 is 12 atmosphere. P1 is 12 atmosphere. Okay. Now cancel the common units. Atmosphere cancels. The unit will be Kelvin. So I am going to get so many Kelvins. Okay. And let us find it using the calculator here. So calculator 14.9 into 300.15 divided by 12, that comes out to be 372.68. So this is 6. So I want 2 decimal point here. So 6, if I remove this becomes 9. So 372.69 Kelvin is the value of temperature. So this implies this is the temperature. So therefore above this temperature 372.69 Kelvin, if you want to convert into degree Celsius, subtract minus 273.15 from it, you will get in degree Celsius. So minus 273.15, if I do, this comes out to be 99.54 degrees Celsius. Above this temperature, the cylinder should explode, because above this temperature pressure will go beyond 14.9, and since cylinder can withstand only 14.9 atmospheric pressure, so it will explode. So this is my answer. Okay. So with this, let's move quickly into the next problem. Okay. So I have a next problem here. Let me take this problem. Okay. Right. Okay. So next problem, we'll solve this. Okay. Answer is already given. So this I don't want. Answer I don't want. Let's see. Okay. A cylinder of 1 liter volume. They have given a cylinder of 1 liter volume. So volume of the cylinder is given as 1 liter. So volume is 1 liter. Is set to be filled with hydrogen gas. So 1 liter of hydrogen gas is there in the container at 27 degrees Celsius and 82 atmospheric pressure. So temperature is 27 degrees Celsius and the pressure is 82 atmosphere. Okay. What they have now, what will be the density of hydrogen? They have asked me to find out the density of hydrogen, and also they have asked me to find out volume of hydrogen at STP. Now here if you just see, density is equal to mass upon volume. And the volume is given to me. So I need to find out the mass, then I can find density. Volume I have to find out at STP. I have to find the volume at STP. Okay. So now see, I have two conditions of temperature and pressure. Condition 1, volume is this much, and if I say STP condition, and you know the STP conditions as, so STP conditions, if I say it as, okay, they have given atmosphere. So we have two STP conditions. Since pressure is given in atmosphere, let me take STP, old STP condition. So STP condition, you know, pressure P2 is, we'll take STP condition P2 is okay, 1 atmosphere, and the volume, sorry, temperature is also fixed at STP. Temperature T2 will take it as 0 degrees Celsius, 0 degrees Celsius. This is 27 means 300.15 Kelvin, and this is 0 degrees means 273.15 Kelvin. Okay. Now you see this volume which I am determining, this is the volume of hydrogen. If I say this as the volume of hydrogen at STP, V2, so I can find out V2 because I have, see, I have two conditions now, V1 T1 P1, V2 P2 T2. So all are changing, all volume, temperature, pressure are changing. So obviously I can use a combined gas law. I can use combined gas law, and that is P1 V1 by T1 is equal to P2 V2 by T2. We can use this equation. So here I will find out the volume at STP. Therefore, volume of hydrogen at STP, means at 1 atmospheric pressure and 0 degree Celsius temperature, will be V2, and that will be according to this equation. V2 I will keep it on this side, rest all I will transfer there. P1 V1 into T2 divided by T1 into P2. Just check, V2 I will kept here, so T2 comes here, P1 V1 T2, P2 comes in denominator, T1 T2. Yes. So let us substitute these values. So I'll get V2 is equal to, so I'll get V2 is equal to, this is the volume. Let's check the volume. V2 will come out to be, P1 is 82 atmosphere into V1 is 1 liter into T2 is 273.15 standard pressure, standard temperature, divided by T1 is given as 327 degrees Celsius, that is 300.15 Kelvin, into P2 is standard pressure, you know it as 1 atmosphere. Okay, let me cancel the common units, and atmosphere cancels, Kelvin cancels. I will get the volume in so many liters, and this is the volume of hydrogen at STP. Let's find out using the log calculator. So this is 82, I am correct, I guess this is 82, yes, 82 is given. So 82 into 1 liter into 273.15 divided by 300.15 divided by 1, that is 74.63 is there, 662. 74.62 liters is the volume of hydrogen at STP. So this is, I have got 74.62 liters volume at STP. This is first solution we have found. Next we have to find out the density of the gas as well. Okay, next to find density, next let us find density of the gas. Now density of the gas, that is dihydrogen, will be its mass upon volume. Okay, its mass upon volume, and I know the mass of the gas is not given, I have to find out. Volume they have given me here as 1 liter. So let me convert into, I can just keep it 1 liter, or 1 liter I can convert into ml as 1000 ml. Okay, mass I need to find out. Now to find out the mass, here is one trick which we have to use from PUC first year, unit number 1. What is that? Now the volume of hydrogen we have found at STP, that is 0 degree Celsius and 1 atmospheric pressure, we have found it as 74.62 liters. Actually, we have converted this 1 liter into 74.62 liters STP condition. Okay, this is same volume, but this is at 74.62. This volume is at the given condition of temperature and pressure. Given temperature is 27 degrees Celsius and 82 atmospheric pressure. Okay, now here the interesting point. STP condition, we know STP condition. So STP condition gives us an idea that at 0 degree Celsius and 1 atmospheric pressure, the volume is 22.4 liter per mole. That means 22.4 liters of hydrogen gas corresponds to 1 mole of hydrogen at STP. But I don't want I want here mass. So mole in terms of mass is molar mass. Mole in terms of molar mass, and molar mass can be found as sum of the atomic masses. So this implies 22.4 liters of hydrogen corresponds to molar mass. Molar mass of hydrogen atomic mass is 1. So 1 plus 1, that is 2 grams. 2. Molar mass is 2. So molar mass is 2. So it is 2 grams of hydrogen at STP. But 1 liter of volume we have converted into STP, and this value has come out to be 74. Therefore, 74.62 liters of hydrogen corresponds to how much volume? If you find how much mass, we will get the mass of this given volume. So mass of this given volume becomes, we just need to cross multiply, that is the mass of hydrogen, that is 74.62 into 2 divided by 74.62 liters. So this is 74.62 liters divided by 22.4 liters into 2 grams of hydrogen at STP. And this value comes out to be 74.62 divided by 22.4 into 2, that comes out to be 6.66. okay, 2 I'll just remove, so this is remain 6 grams. See, liter cancels, unit will be in gram. Here check, the unit of liter cancels, unit will be gram. Okay, so I have got the mass as 6.662. Substitute in this equation, therefore 6.66 divided by 1000, that comes out to be 6.66 into 10 to the power minus 3. This is grams per ml, and this is the density of hydrogen gas, and this completes the problem. Okay, I hope you have understood this. Let's go with the next problem. So I have a next problem for you. Okay, let's move on to the next problem. Okay, let's move on to next problem. So I have a next problem here. This is the problem. What they have given: a Dranex cleaner contains Dranex contain a small bit of aluminium. Okay, it says they have a small bit of aluminium which reacts with caustic soda. Caustic soda is NaOH and forms hydrogen. What volume? They have asked what volume of hydrogen is hydrogen at 20 degrees Celsius and 1 bar will be released when 0.15 grams of aluminum reacts. Now this is a problem from stoichiometry of unit number 1. So let us solve this. Now they have given me reaction. Okay, the reaction tells me that, I'll write the reaction here. It is 2Al plus 2NaOH plus 2H2O gives me 2NaAlO2 plus 3H2. Now this everything is unwanted stuff. They have just correlating aluminium with dihydrogen. They are correlating, so this equation correlates that 2 moles of aluminium gives me 3 moles of hydrogen. 3 moles of hydrogen by balanced equation. Now aluminium they have given in mass, so if you want to convert this mole into mass, it is molar mass. 1 mole is molar mass. 1 mole is molar mass. So 2 into molar mass of hydrogen. 2 moles means 2 into molar mass of hydrogen. That is 2 into molar mass. I want this in terms of mass because aluminum is given as mass. So it is 2 into molar mass. Molar mass of aluminium is 27. So it is 2 into 27 grams per mole. This, and I want this to convert into molar volume because I want molar volume, and molar volume if I want to convert, 1 mole means molar volume. So it is 3 into molar volume, and you know molar volume. So let us, they have given me in SI unit in they have given bar. So we will take new SI unit, molar volume, SI unit molar volume at STP, that is 0 degrees Celsius and 1 bar pressure. The molar volume is 22.7 liters. So it is 3 into 22.7 liters. So this equation gives me an idea. So this reaction implies, to me that 2 into 27, I just find it, this is 2 into 27, that comes out to be 54 grams, and 3 into 22.7, into 3 will give me 68.1 liters. So the equation gives me the idea that 54 grams of aluminium gives 68.1 liter of hydrogen at STP, that is at 0 degrees Celsius and 1 bar pressure. But they have given me 0.15 grams. So therefore if I just have to find out 1.5 grams of aluminium gives me how many volumes of hydrogen, cross multiply, it becomes 1.5 grams into 68.1 liters divided by 54 grams of hydrogen at STP, that is 0 degrees Celsius and 1 bar pressure, and this value will come out to be 1.5 into 68.1 divided by 54, that comes out to be, so we will take 2 decimal point, this is 1.89 liter of hydrogen at STP is 1.5 grams of aluminium gives this. But STP, they have not asked me at STP, they have asked me at LTP. They have asked me this volume of hydrogen at given condition, at given temperature and pressure. At given temperature is you see given temperature is 20 degrees Celsius. So 20 plus 270, 20 degrees Celsius plus 273.15 Kelvin, and given pressure is 1 bar. So just see, we have volume, say I'll say this is I have volume, temperature, pressure, volume, temperature, pressure, 2 temperatures and 2 volumes. So if I say this is, and if I say this as V1, I'll say this as V1, and this I will say as T1, and this I'll say as P1. Then I can apply combined gas law very easily and find the V2. combined gas law implies P1 V1 by T1 is equal to P2 V2 by T2. Let this be given condition and this be STP condition. So given condition I need to find out, okay, no, reverse. Let this be STP condition and this is given condition. Okay, so given condition volume I need to find out. So V2 will become equal to P1 V1 into T2 divided by T1 into P2, that is, okay, let me substitute the values. P1 STP, see P1 is STP, okay, I have taken, okay, okay, STP temperature P1 0 degree Celsius, so pressure 1 bar, V1 volume V1 is this, which we have calculated just now, 189 liters into T2 is the given temperature, that is 293.15 Kelvin, 20 plus 273.15 divided by T1 is given temperature, T1 is standard temperature is 0 degree Celsius, 0 degree Celsius means 273.15 Kelvin into P2 is a standard pressure, P2 is not standard, given pressure is how much, 1 bar. Okay, so let us cancel the common units first. 1 bar cancels, Kelvin cancels, answer will be in liters. So I need to use the calculator, final thing, 1.89 into 293.15 divided by 273.15 divided by 1, that is 2.03 will make 8. If you want to remove, then 2 decimal point will make it 3. This is 3, 2.203 liters, 2.03 liters of volume. So this is the answer which I wanted. So therefore I will conclude, therefore the volume of, so see how they have asked the volume of hydrogen released, therefore 1.5 grams of aluminium release 2.03 liters of hydrogen at the given temperature 20 degrees Celsius and 1 bar pressure. This is my answer, right? So this is the problem. Let's quickly move on to the next problem now. So next problem I am taking is this one. Okay, let me take this problem. Okay, so I just need to go for this, delete this, and then this is the next problem. Okay, so see the temperature. Calculate the temperature of 4 moles of a gas occupying 5 dm cube at 3.32 bar. Okay, so here what is given? Let's see, they have asked me to find out temperature. For that they have given number of moles. Okay, let me use scientific notations, what they have given. So it is 4.0 moles. They have given volume as well, 5 dm cube. They have given pressure as well, 3.32 bar. Okay, now you correlate the relation between pressure, volume, number of moles and temperature, and that is the ideal gas equation. That is the ideal gas equation, PV is equal to nRT. So here I just have to find out the temperature. So temperature on one side, rest all on the other side. So PV upon nR. So P, pressure is given 3.32 bar, into V, volume is given 5 dm cube upon n given 4 moles into R. Now here R is a universal gas constant, okay, and the value of R can be chosen based on the unit of pressure and and volume. So here volume is dm cube, that is liter, and bar. So that unit is, they have given, sometimes if it is not given then you should know dm cube and bar. Dm cube is liter, bar and liter. So I need to use this 0.083 bar dm cube per Kelvin per mole. Okay, so cancel the units to get the unit of the answer. Bar is cancelled with this, mole per mole cancels, then dm cube cancels, unit remains is per Kelvin in the denominator. So when it comes in numerator it becomes Kelvin. So answer you will get in Kelvin. So just have to use the calculator now. 3.32 into 5 divided by 4 divided by 0.083, that comes out to be 50 Kelvin. They have given temperature in degree Celsius. So if you want to convert it into degree Celsius, subtract 273.15 from here, you will get in degree Celsius. You will get in degree Celsius. So that is minus 273.15. That will be a negative figure, minus 223.15 degrees Celsius. This is the answer. See, the degree Celsius have a negative value, therefore we always convert temperature into Kelvin, so that the values calculated will never be a negative figures. Right. Let's quickly move on to the next problem. Let's quickly move on to the next problem. So I have a next problem for you. Okay. So next problem. The next problem is here. Calculate the volume. They have said calculate the volume of 8.9 grams of carbon dioxide. They have given me 8.8 grams of carbon dioxide at 31.1 degrees Celsius and 1 bar pressure. They have given. They have asked me to find out the volume. So volume is asked. They have given the mass 8.8 grams of carbon dioxide. They have given the temperature 31.1 degrees Celsius. They have given the pressure 1 bar. Okay, so here volume, temperature and pressure, they all three are related by only one equation, that is ideal gas equation. And you know the ideal gas equation is PV is equal to nRT. Okay, now here P is given. Okay, so here V is equal to nRT upon P. Okay, now here number of moles is not known to me. Number of moles is not known to me. Number of moles is not known to me, and you know the number of moles. For that they have given the mass. And just recall, I have told you, you need to remember the equation. Number of mole is equal to mass upon molar mass. Mass upon molar mass. Okay, so mass, number of mole is mass upon molar mass. Okay, mass is given as 8.8 grams divided by molar mass. Molar mass of carbon dioxide, they have given the formula of carbon dioxide. Molar mass is sum of the atomic masses. Sum of the atomic masses. So carbon atomic mass is 12, oxygen atomic mass is 16 into 2, that is 32. So total comes out to be 44 grams per mole. So this is 44 grams per mole. Here again just check the unit of gram cancels, per mole comes in the numerator, so value of n comes out to be so many moles. So we'll calculate that, that is 8.8 divided by 44, that comes out to be 0.2 moles. So I can substitute here. So volume will become equal to number of moles 0.2 moles into R. Okay, R I don't know, let's check R, which R to be put, we'll see which R to put. Temperature they have given me in 31.1. So temperature in degrees Celsius converted into Kelvin, 31.1 plus 273, sorry, 31.1 plus 273.15, that comes out to be 304.25, 304.25 Kelvin divided by pressure. Pressure is given as 1 bar. I will just keep. Now here the volume, if I want in liters, unit is given in bar, so we will take the value of R in SI unit, in bar, that is 0.083 bar per liter per Kelvin per mole. Okay, so cancel the common units. Let's see what unit you are going to get. Mole per mole cancels, Kelvin per Kelvin cancels, bar in the denominator, bar in the numerator cancels, unit will remain as liters, so many liters. So let us calculate that, that is 0.2 into 0.083 into 304.25 divided by 1, that is 5.05, 5.05 liters is the answer, Okay, let's quickly move into the next problem. Let's quickly move on to the next problem. So the next problem is here. The density of the gas. Okay, I'll take this problem. Okay, let's quickly move on to the next problem. The last problem of today's class, and that completes my problems on gas laws. If possible, I'll finish one more problem. Okay. Gaseous mixture of 750 mm of pressure in a cylinder has 0.60 grams of A and 0.45 grams of B. Find partial pressure of both the gases. They have given molar mass of A as 60 and B as 45. Okay. They have asked me to find out the partial pressure, and they have given total pressure. They have given the mass of every component and the molar mass of every component. And you know, the partial pressure by definition is equal to total pressure into mole fraction. And the mole fraction is to be found out. Okay, total pressure is given to me. So if I want to find out the partial pressure of A, the partial pressure of A will be equal to P total is given as 750 mm into mole fraction I need to find out, and the partial pressure of B will be, and the partial pressure of B will be again total pressure 750 mm into the mole fraction. Now here I need to find out the mole fraction. You know, mole fraction is nothing but number of moles of that component upon total number of moles. So number of moles is not given, they have given mass, and mass and molar mass is given, means you know number of mole is equal to mass upon molar mass, we can find out. So number of moles of A will be mass given as 0.60 grams divided by 60, and number of moles of B is grams per mole, unit of molar mass, and B is given 45, so 0.45 grams upon 45 grams per mole. So unit Na will become, let's check. So Na 0.60 divided by 60, 0.01 mole, and Nb also will be 0.01 mole. Now 0.45 divided by 45, that comes out to be, just check, 0.45 divided by 45, that comes out to be same 0.01 mole. Okay, so now I just have to find out the mole fraction. Mole fraction is number of moles of that component. So mole fraction of A is equal to number of moles of A upon total number of moles. So that is number of moles of A 0.01 divided by, see, mole upon 0.01 mole plus 0.01 mole, that is 0.02 moles. So divided by 0.02 moles, that is 0.5. So XA comes out to be 0.5. So you substitute here 0.5. Similarly, you can find out the mole fraction of B. Mole fraction of B as 0. So 0. They have given 40, right? Okay. 45 and 45. Okay. So number of moles is 45 upon 45. That is okay. Same 0.1. Same number. Same I'll get. So I'll just substitute. I'll just find out the same answers. I'll get the answer. That is the mole fractions. This completes the problem. This completes the problems. One more last problem is there that I will take and I'll stop. Problem on. Okay, the last problem. What will be the pressure exerted by the mixture of 3.2 grams of methane and 4.4 grams of carbon dioxide containing 9 dm³ flask at 27 degrees Celsius? Okay, so we have a mixture of gas. We have a mixture of gas, right? We have a mixture of gas containing 3.2 grams of methane, the formula of methane is CH4, and 4.4 grams of carbon dioxide, and the volume of this container is 9 dm³ at a temperature of 27 degrees Celsius. They have asked me to find out the total pressure. Now they are the mixture of non-reacting gases. So total pressure is equal to sum of the partial pressures of the individual gases. We have this. We need to find out the partial pressure. For finding partial pressure, now partial pressure is, we have a formula, total pressure into mole fraction. Total pressure into mole fraction. Okay, but mole fraction, total pressure into mole fraction. And in this problem they have not given me mole fraction, they have not given me total pressure as well. In fact, we have to find total pressure. So I can't use this equation. I can't use this equation. Okay, so I can't use the equation. I can't use this. So let me just remove this. I can't use this. Okay, so partial pressure formula was known as P is equal to P total into mole fraction. Okay, I can't use this because I have to find out total pressure. Okay, for this they have given me volume and temperature. Volume, temperature and P. Do I know the relation? Yes, I know the relation. The volume, temperature, V relation is the ideal gas equation, and that is PV is equal to nRT. PV is equal to nRT. So can I find that? Can I find PV is equal to nRT? Okay, let us find number of moles. I have to first find out. So for oxygen, for methane gas, let us find out. So here I need number of moles of methane gas. Number of moles of methane gas is equal to mass upon molar mass. So mass is known to you as they have given you 3.2 grams upon molar mass. Molar mass of carbon, atomic mass of carbon is 12. Atomic mass of carbon is 12, hydrogen is 1. So 12 plus 4 into 1, that is 12 plus 4, 16. 16 grams per mole. I get the number of moles of hydrogen. I'll substitute. That value comes out to be 3.2 divided by 16, that is 0.2 moles. 0.2 moles. Okay. Similarly, we'll find out for carbon dioxide. So for carbon dioxide, number of mole is N2. Number of mole N2 is say W upon M. Okay. W mass is given as 4.4 grams. The mass, molar mass is sum of the atomic masses. Carbon atomic mass is 12, oxygen is 16. 12 plus 16 plus 16. 12 plus 16 plus 16, if you just see it, is 44 grams per mole. 12 plus 16 plus 16, 44 grams per mole. So if I just again divide 4.4 divided by 44, I'll get 0.1 moles. So this is 0.1 moles. We have found 0.1 moles. Okay. So we have found. So therefore, the pressure of methane will be what? From equation 1 implies equation 2 if I say. So from equation 2, pressure of methane is nRT upon P upon V. nRT upon V. Okay. So volume is fixed. You know, pressure is N. N is 0.2 moles into R is okay. Now here we have taken pressure in okay, we'll take pressure, we'll take 8.314 joules per Kelvin per mole. That's not a problem. Into temperature 27 degrees Celsius, that makes it 300 Kelvin, divided by volume is given as 9 dm cube. So let me write 9 dm cube. Okay. Now they have given the volume in dm cube, so I need to use 0.03. I can't use this. I can't use this value of R. dm cube is given, so we'll use the value which is just now given to you, given to me, that is 0.0831 dm cube bar per Kelvin per mole. Okay, we'll use this value. So this comes out to be, okay, we'll find out 0.2 into 0.0831 into 300 divided by 9. I have got the partial pressure of methane as 0.554. What will be the unit? Check out. Mole per mole cancels, dm cube cancels, Kelvin per Kelvin cancels. I'll get the answer in bar. So this is so many bars. Similarly, I can find out the pressure of carbon dioxide as well as nRT by V. So N is 0.1. Okay, rather than this, okay, I have to find out. So 0.1 mole into 0.0831 dm cube bar per Kelvin per mole. I hope you have understood why I am taking this value of R, because we have dm cube in this equation, into 300 Kelvin, temperature remains same, volume also remains same, 9 dm cube. So I just have to find out here. This is 0.1 into 0.0831 into 300 divided by 9, that comes out to be 0.277 bar. This is the pressure, and therefore total pressure is equal to sum of this, that is 0.554 plus 0.227, that comes out to be 0.554, that comes out to be 0.831 bar. This is the answer, and this completes the problems on gas loss. Any other problem comes to your mind and you are not able to solve it, please bring it to my notice, or you can post it in your Google Classroom, I will be able to solve that. Thank you. We will stop here.